Children, today we will start from heading Mechanism of Electrolysis. Ionization of covalent compounds. Example, HCl. So you all know that HCl is a type of polar covalent compound. Polar covalent compound means due to the electronegativity difference of the Cl and hydrogen, the shared pair of electrons get attracted by this Cl atom more strongly, and that is why it exerts partial negative charge, and against to this partial negative charge this hydrogen atom becomes partial positive charge. So due to these charge separation, this molecule become polar in nature. That is why it is known as polar covalent compound, and the bond present between HCl, H and Cl is known as polar covalent bond. So polar covalent compounds like ammonia, hydrogen chloride are non-electrolytes in gaseous state due to the absence of ions, but ionize in aqueous solution state. So in aqueous solution, in the presence of water, these polar compounds get converted in the form of ions. Okay. So the reaction of the polar covalent compound when these dissolves in water and get converted in the form of ions, this change is known as ionization. Okay, this change is known as ionization. So hydrogen chloride in the gaseous state or in the pure liquid state is unionized and does not conduct an electric current due to the absence of ions. Hydrogen chloride is however polar covalent in nature, that is shows charge distribution of its molecules such that the hydrogen atom has a slight positive charge and chlorine atom has a slight negative charge. As I told you already this thing here. The next point, when hydrogen chloride is added to water, water is a polar solvent. The slightly negatively charged oxygen atom of the water exerts an electrostatic pull on positively charged hydrogen ion of HCl. Okay, so H plus ion combined with the water forming hydronium ion, and the residual chloride ion remain in solution. Hence ammonia or hydrogen chloride in gaseous or pure liquid state does not conduct electricity but conducts electricity when dissolved in water. So in gaseous state or in the form of covalent molecule, but in aqueous state these molecules, polar molecules, converted in the form of ions. So due to the presence of ions in aqueous state, ammonia and HCl, which are polar covalent compound, are conductor of electricity. So as you can see here, ionization of hydrogen chloride molecule in aqueous solution. This is the polar covalent compound HCl, and this is polar covalent solvent water. This is partially negatively charged site of the water molecule and partially positively site of the water molecule. Now when HCl is dissolved in water, then this oxygen will attract hydrogen atom towards itself, okay, due to this opposite charges, and due to the this electrostatic force of attraction, this H will become out, and this H with a water molecule get converted in the form of hydronium ion, and this Cl minus ion will be remain free in the aqueous medium. So two ions will be formed, H3O plus hydronium ion and chloride ion. So due to the presence of these ions in aqueous solution, HCl shows conductivity of electricity in aqueous solution state. Then comparison between metallic conduction and electrolytic conduction. So metals, the flow of electricity takes place by flow of electrons, and these electrons are known as free electrons, which have negligible mass, but the flow of electricity takes place by flow of ions, and which are denser compared to electrons. So ions are having some mass, but electrons are having negligible mass. Okay, so when electricity pass through the metal, there is no change in the mass, but when electricity pass through any electrolytes, there will be change in mass also. Then there is no decomposition of the parent metal, and so the chemical properties of metal are intact. But here decomposition of the electrolytic solution, and so the chemical properties of electrolyte are changed, altered. Metals are good conductor of electricity in solid state and in molten state, but electrolytes are the good conductor of electricity in their aqueous solution state or molten state, but not in solid state. Why? Because in solid state electrolytes are not having free ions. During metallic conduction there is no transfer of matter, but here in electrolysis there is a transfer of ions. Ions means matter or substance. The flow of electricity only produces heat energy and no new product are formed in the case of metallic conduction. But the flow of electricity decomposes the electrolyte and new products are formed at respective electrodes. Okay students, the example is given here. Copper metal is so a good conductor of electricity but is a non-conductor, a non-electrolyte since it does not undergo chemical decomposition due to flow of electric current. Okay, copper metal conductor of electricity but non-electrolyte because in the presence of electricity there is no any such type of decomposition is taking place. But copper 2 sulfate on the other hand is an electrolyte because it decomposes on passage of electric current, forming copper ions and sulfate ions. The copper ions are discharged at the cathode as copper metal when copper electrodes are used during electrolysis. Okay students, so this is the difference between metallic conduction and electrolytic conduction. The next heading is acid, bases and salts and electrolytes. So acid, bases and salts are considered as an electrolyte. So one experiment is given. What is the aim of this experiment? To determine whether a given compound A that can be acid, base or salt in the fused or aqueous solution state is a strong electrolyte or weak electrolyte. So such experiment we have seen in starting of this chapter also. Okay students, so if the glow of this bulb will be bright, then the related electrolyte will be strong electrolyte due to the greater number of formation of ions, presence of ions or higher concentration of the ions. But if this is the glow of bulb is dim or dull, then electrolyte will be weak, and if there is no any glow in this bulb, then this electrolyte will be non-electrolyte. It will be not an electrolyte, it will be a compound or a solution of a non-electrolyte. Okay students, the next page. Acid, bases and salts and electrolytes. Acid, bases and salts. Acid, bases and salts when dissolved in water or in the fused state dissociate into free mobile ions and can be classified as strong or weak electrolytes depending on the degree of dissociation. So if the degree of dissociation is higher, that electrolyte will be strong. If low, electrolyte will be weak. Strong electrolytes. Compounds which in the fused or in the aqueous solution state are almost completely dissociated are good conductors of electricity and are called strong electrolytes. So completely dissociated means if you taken two molecules of any electrolyte and these two molecules are get converted in the form of ions. So about complete dissociation will be there, and such electrolyte will be known as a strong electrolyte. Weak electrolytes, compounds which in the fused or in the aqueous solution state are feebly or partially dissociated and are poor conductor of electricity are called weak electrolytes. So weak electrolytes are partially dissociated means if you taken two molecules of an electrolyte and just one dissociated in the form of ions. Okay, so one molecule will be remain in the form of undissociated molecule. Out of two, one undissociated and the one will be in the form of ions. So such type of electrolytes will be known as weak electrolyte, and due to the comparatively less concentration of ions, this will show less conductivity of the electricity. Okay students, then classification of acids, bases and salt into strong and weak electrolytes. So acids or mineral acids ionize or dissolution in water furnish H+ ion solution. Bases ionize in fused or in aqueous solution state furnish OH- ions in solution. And salts, ionic salts ionize in fused or in aqueous solution state furnish positive ions other than H+ ion and negative ions other than OH- ions. Okay students, so salts are such compounds which are producing positive ion other than H+ ions and negative ions other than OH- ions. Then strong electrolytes like hydrochloric acid, it will dissociate completely. Nitric acid dissociate completely. So this H plus NO3 minus. H is with +1 charge, so nitrate will carry 1 negative charge. Sulfuric acid H2SO4, 2H plus SO4 minus, SO4 minus. Same way strong electrolytes, so all alkali are strong electrolytes which dissociate completely in the form of ions. Same way salts, lead bromide, copper chloride and silver nitrate, these are dissociate about completely. So strong salts, strong electrolytes. Then weak electrolytes like organic acids, acetic acid, formic acid and this carbonic acid. These acids dissociate partially. So weak electrolytes. Weak electrolytes, bases calcium hydroxide, magnesium hydroxide and ammonium hydroxide. So all such hydroxides which are having more than 1 OH- ions are weak electrolytes, and the exception is one here, this ammonium hydroxide, which is having 1 OH but it is a weak electrolyte. Okay students, so all such alkalis which are having OH- ion more than 1, 2, 3, 2 are present here, FeOH whole thrice 3. So these all will be weak electrolyte, and this is exceptionally weak, having 1 OH- ion. Then weak electrolyte salts, sodium carbonate, potassium bicarbonate and lead acetate. These all are weak salts. Okay students, next page. Electrochemical series. So what is electrochemical series? So depending on the ease with which the metals lose their electrons and form ions, they are arranged in a series known as metal activity series or electrochemical series. So this is the metal activity series students. Okay, so here in this series metals are arranged according to their ease of losing electron. So according to this series, the electron losing ability is going decrease. It is decreasing from up to down. Okay, so potassium can lose its electron most easily and silver most hardly according to this series. Okay, so the arrangement so done that the element that ionize most readily are placed at the top of the series and other elements in the descending order. At the top of the series, metals which ionize most readily or most easily are included at the top of the series. So metal will lose electron and will convert in the form of positive ions. For example, potassium at the top of the series losing electron converted in the form of potassium ion. Positive ions or cations formed are discharged at cathode. Okay, why? Because cathode is a negative pole of the electrolytic cell with most difficulty. Okay, students. So the ions which is formed due to the loss of electron most easily will discharge with most difficulty at the cathode. At the lower end of the series, metal which ionize least readily are included at the lower end of the series. For example, copper and silver. Copper, after losing electron, get converted in the form of Cu2 plus ion, and silver as Ag plus ion. So loss of electron is there, that is why this reaction will be known as oxidation reaction. Oxidation reaction. Okay, students, and in this reaction here, gain of electron is there, so it is a reduction reaction. Okay, so oxidation reaction. Now positive ions formed are discharged at the cathode most easily. Okay, so positive ion which are formed most hardly can discharge most easily. Okay, so as you can see from this series, if in an electrolytic medium you are having potassium ion and ferrous ion both. Okay, students, potassium ion and ferrous ion are both, then according to the preferential discharge, ferrous ion will discharge first at the cathode. Okay, because discharging of this ion will be comparatively harder because it is at the top of the series. Okay, because potassium is forming these ions most easily, so discharge of these ions will be most hard. But as we move from up to down in this series, the discharge of positive ions at the cathode will become easier. Okay, so out of iron and silver, the discharge of silver at the cathode will be easier one. Okay, students, then discharge with most difficulty. Positive ions discharge at cathode by gain of electrons. Okay, cathode is negative pole. The tendency of the cations to get reduced at the cathode increases on descending the electrochemical series, as I explained you here. Then discharge with most difficulty. Negative ions discharge at anode by loss of electrons. The tendency of the ions to get oxidized at the anode increases on descending the electrochemical series. So this is the sequence of the series, and the discharge of these negative ions increases from up to down in the series. Okay, students, means if you are having the sulfate ion and hydroxide in electrolytic medium, then this hydroxide ion will discharge comparatively more easily than the sulfate ion. So preferential discharge of OH minus ion will takes place at anode. Okay, students, so this series is very important for the discussion of the preferential discharge of the ions. The next page, selective discharge of ions. Term: the preferential discharge of ions present in an electrolyte at the respective electrodes is also known as selective discharge. So if in any electrolyte more than one type of positive ions or more than one type of negative ions are present, then in this condition preferential discharge will take place of a particular ion. Okay, students, factors affecting selective discharge. First factor is relative position of the cations or anions in electrochemical series, and it is the most important factor. Lower the position of the ion forming element in the electrochemical series, greater the tendency to be liberated at the respective electrode. So in electrochemical series, the position of ion will be lower, means it will be easily discharged at the related electrode. Okay, students, discharge of cations and anions at the respective electrodes. So as you can see here, cations, if you are having copper ions and H plus ions, then migrate to cathode. So these two, because positively charged ions will migrate towards the cathode, but copper ion discharge at cathode. Okay, so preferential discharge of copper ion will takes place. Okay students, why? Because in electrochemical series or metal activity series, copper ions are placed below to this hydrogen ion. Okay, so preferential discharge will take place of these copper ion because these are present in below position than the hydrogen ions. Same way, out of silver and hydrogen ion, silver ions discharge at cathode because silver ion placed below to the hydrogen ion. Same way, anions, sulfate and hydroxide ions, these will migrate towards the anode. Anode is positive pole of the cell, and OH minus ions discharge at anode. Why? Because OH minus ions placed here are below to sulfate ion. Okay, so this will discharge at anode first. Then second point is concentration of the ions in the electrolyte. So higher the concentration of the ions, greater the probability of it being discharged at the respective electrodes. Okay students, so if a particular ion is having more concentration than the other ion, then the preferential discharge will take place of that ion which is having more concentration. Now this point we can understand with the help of this example: electrolysis of dilute NaCl solution and electrolysis of concentrated NaCl solution. So when NaCl will dissociate in aqueous condition, then these positive ions and these negative ions will produce. Here also same positive and negative ions will produce. At cathode, H plus ions discharged and anode OH minus ion will discharge. But here in this, Na plus and H plus ions are migrate, and anode these two ions will migrate. Now what will happen here? H plus gains electrons more easily than Na plus ion. OH minus ion preferentially discharged due to the lower position in electrochemical series. Okay, so preferential discharge of OH minus ion because it is present at lower position than the Cl minus here in electrochemical series. And out of H plus ions and Na plus ions, H plus ion gains electrons more easily than Na plus ion. Why? Because H plus ions are present below to the Na plus ions in electrochemical series. Okay students, then that is why at cathode hydrogen will evolve and at anode oxygen will evolve. Then in the case of concentrated NaCl solution, despite high concentration of Na plus ions at particular concentration, H plus ion gains electrons more easily than Na plus ions. So Cl minus preferentially discharge due to high concentration of Cl minus ions. Okay, so Cl minus ion will discharge here. You have to keep in your mind that in the case of concentrated NaCl solution, Cl minus ion will discharge at the anode. Why? Because its higher concentration will be present in concentrated NaCl solution. So the discharge of H plus ion is taking place according to the electrochemical series or reactivity series, but this discharge of Cl minus ion is taking place due to its higher concentration in the solution. So at cathode you will get hydrogen, same here, but at anode chlorine gas will be evolved here, but here in the dilute solution O2 will be evolved. Okay, so this difference you keep in your mind because you haven't any practical any experimental instrument to check which ion is having a greater concentration in which medium. So just keep in your mind this point that in the case of concentrated NaCl, Cl minus ions discharge at anode. That is why you will get chlorine at anode. but in an dilute NaCl solution, the discharging of ion is taking place according to reactivity series or electrochemical series. Then third point which govern discharge of ions is nature of the electrode. So determines the preferential ions which will be discharged at the electrode. Inert electrodes like iron, graphite, platinum, which do not take part in electrolytic reaction, and active electrodes like copper, nickel, silver takes part in electrolytic reactions. Okay, so active electrode like copper, electrolysis of copper sulfate solution. So if active electrode copper is present, then electrode cathode is copper, anode is copper. Then reaction at anode will be this, and product will be Cu2 plus ion. So from anode, because anode of copper, so this anode will take part in electrolytic reaction, okay, and it will produce copper ion. Okay students, aqueous copper sulfate solution. So aqueous copper sulfate solution will produce two type of positive ions and these two negative ions. Okay, now when inert electrode platinum is there, then what will happen? Cathode is of copper and anode is of platinum. So in this condition, this platinum anode will not take part. Okay, it is not going to take part in chemical reaction, in electrolytic reaction. So a reaction at anode, what will be there? OH minus ion will be collected and this converted in the form of oxygen. So if you are using this electrolyte copper sulfate for electrolysis in the presence of active electrode copper, so anode will be of copper only, and in that condition anode will take part in electrolytic reaction and it will produce copper ion. Okay, but if you are using for the electrolysis of this solution in the presence of inert electrode platinum, then this platinum will not take part in a reaction and OH minus ion will collected at the anode, and due to the collection of these OH minus ions, final product you will get oxygen at anode. Okay, so this is the difference. This is the difference of the product due to the presence of active electrode or inert electrode. Now hence, if the electrode is an active electrode, that is copper, nickel or silver, the ions sulfate and OH migrate to the anode but are not discharged. Why? Because these electrodes themselves are taking part in chemical reaction and producing related positive ions. But instead the active electrode itself, the ions loses electrons and form ions like copper, nickel and silver at the anode. Okay, so if active electrodes are present, then these ions will form. Okay students, the next page. Example of electrolysis. So first example is electrolysis of molten or fused lead bromide. So as you can see here, this molten lead bromide is taken in a porcelain dish. Two electrodes are used, graphite anode and iron or graphite cathode. This is the source of electricity, battery. This is key or switch. This is ammeter to check the amount of electricity. Okay, so electrolytic cell, non-conductor vessel is made up of silica crucible. So this is the silica crucible. Electrolyte, molten lead bromide. Cathode, electrodes, cathode, iron or graphite. Anode is graphite. So iron or graphite, inert electrode. Anode of graphite is also inert electrode. Temperature 380 degree above. Current 3 ampere round. Electrode reactions. So dissociation of first lead bromide. So lead bromide will dissociate to form lead ions and bromide ions. So in the solution, ions present, lead ions, positive ions, and bromide ions, negative ions. Now reaction at the cathode. Cathode is the negative pole of the cell. So lead ions will collected at the cathode and will take electrons from the cathode and get discharged in the form of lead Pb. Lead ions are discharged at the cathode as neutral lead atoms by accepting electrons. And product at cathode will be lead metal, silvery gray deposit, reduction reaction. Because gain of electron here, so it is a reduction reaction. Then reaction at anode, bromide ion will collect at anode because anode is positive electrode of the cell. So bromide ion will lose electron, will get converted in the form of Br. This Br and Br in the form of bromine. So bromide ions are discharged at anode as neutral bromine atoms by giving up electrons. Bromine atoms form molecule of bromine. Product at anode, bromine vapors, reddish brown fumes. Oxidation reaction because loss of electron is taking place. Electrolysis of molten lead bromide involves oxidation and reduction both. So it is a type of redox reaction. Okay students, so electrolysis of lead bromide is a type of redox reaction because both oxidation and reduction are taking place simultaneously. Thank you.